Okay, this is the M1 paper from October 2020. It's question number 7. As you can see by looking at it, this is a Pulleys question, so it's dynamics, connected particles. Pretty standard Pulleys question. One thing I would say is there's just 8 marks for going all the way through it. They haven't broken it down into different parts, like find the equation of motion for A, equation of motion for B, or whatever. But let's have a look at it and see what we've got going on. So we've got our usual things. It's a light inextensible string. We've got 2 masses, one's 5m, one's 3m. It's a smooth pulley. And then particle A is held at rest. Particle A is released. What happens? What have we got to do? We've got to find the magnitude of the force exerted on the pulley. Yep, so we just need to talk about that a little bit at the end. But in effect, what I've got to do, set up my system, work out the acceleration, work out the tension, and then once I've got those 2 things, I can find the force on the pulley. Let's get started then. So with this, I always draw out my own diagram. So we've got our pulley here, a mass on one side, a mass on the other side. If this is particle A, then the weight is 5 mg. If this is particle B, then the weight is 3 mg. And we've got a tension acting up there and a tension acting up there. If they hasn't mentioned the pulley, I'd just stop at that point. But because what they actually want is the force acting on the pulley, I'm going to put those 2 forces on, and we can talk straight away now and say the force acting on the pulley is just going to be 2t. So in effect, what I've got to do is to find t, and then I can just double it for the force acting on the pulley. Which way is this thing going to be going? Well, the A is heavier, so the acceleration is going to be going downwards in that direction and upwards in that direction. And so now all I need to do is tell the examiner what I'm going to start off with. It doesn't really matter the order in which we do it. I'm going to consider particle A first of all. I'm going to resolve vertically, which is F equals ma. Vertically, I've simply got those 2 forces acting, and because acceleration is going down there, we know the 5 mg is bigger than the t, so I get 5 mg minus t equals 5 ma, and that becomes my first equation of motion. Nothing surprising about that one at all. All I've got to do now is to do a similar thing for B. So consider B. Again, resolve vertically, which again is going to be F equals ma. And if we look at B this time, because I know it's accelerating upwards, we know that it's going to be t minus 3 mg. And for anybody who's been doing these questions, not only is that not a surprise to me, so t minus 3 mg equals 3 ma, which gives me, equation number 2 here is if I put 1 and 2 together here, so I'll just put number 1 underneath it. That's absolutely what I was expecting to have happen, is t and minus t, because I'm going to add them together and they're going to cancel out. Even on the more complicated ones, we should still get an equation with t and with minus t when I'm going through. Other things might be a bit more complicated, but certainly with this one, let's just be grateful for the fact that there isn't anything complicated here. Add the 2 of them together. I'm going to get 5 mg minus 3 mg, so that's 2 mg. I'm going to get 5 ma plus 3 ma, so that's 8 ma. Cancel the m's. I'm going to get that A works out to be equal to g over 4. Right, perfect. Once I've got A, I can then just put that into either of the 2 equations. I'm going to put it into equation 2. And the only reason I'm putting it into equation number 2 is because, that's good news, Arsenal winning. I'm going to put it into number 2 because I've got t minus. So if I've got t minus 3mg is equal to 3mg over 4 then. So T works out to be 3mg over 4 plus 3mg. That works out to be 15mg over 4. And now what we've got to do is just remind myself that the question asked for the force exerted on the pulley. And again, this is really straightforward. They could have made this much more difficult. But in this case, force exerted on the pulley is just equal to 2T. So that's equal to 15 mg over 2. So that's my actual answer for the first part. And then the second part, this is one of these questions that they ask us. I've got a separate video on this, which is just talking about all the various different scenarios that you could have, the modelling scenarios that you could have. And in this case, if the pulley is smooth, when the pulley is smooth, what that tells me is if pulley is smooth, then the tension is the same. And just to be absolutely accurate, the tension is the same on both sides of the pulley. You could say the tension is constant on both sides of the pulley. On both sides of the pulley. Yeah, go and have a look at that video and it gives you the 5 or 6 different versions that we might have. But really straightforward question, so hopefully that makes sense.